Hi everyone, and welcome to yet another
The Earth is Flat on Planet Pluto.
an online live cosmic talk show about astronomy, science, and other stuff, where the guests are the clear highlight and where you can ask any questions by using the chat over here and also participate. Now, every Wednesday at 5:30 p.m., we will bring you a cosmic topic and amazing guests who will share their passion for science and space. My name is David Sobral, and I'm an astronomer and a scientist. Just like everyone else on this amazing yet insignificant planet, I'm 90% made of stars and 10% made of cosmos. Just in case you didn't know, this is what we're all made of. And I think it's really important to highlight that by looking up and facing how big the universe is and full of galaxies, we're always forced to make a very simple conclusion that is as dark as poetic and inspiring. And this comes from the words of an amazing poet saying that we are nothing, we will always be nothing, and we cannot even aim to be anything but nothing. Yet as humans, and particularly when we work together and overcome differences and silly walls and boundaries, we have in us all the dreams in the world. So I think it is really important to be okay and embrace our beautiful insignificance, and yet continue to inspire others to break boundaries, walls, and dream even higher. Now, in this second episode, just like in all others, things can and will definitely go wrong. And again, I must stress that this is part of the scientific method. And this is also because when things work perfectly, we never really learn anything at all. During June and July, if things go to plan, I shall be your host as we attempt to bring you lots of astronomy, science, experiences, the human side of looking up, and also a lot of fully random but hopefully fun stuff. So the bottom line is there will be stuff, lots of stuff, and particularly cosmic stuff weekly. In today's second episode, we have even more people watching because everyone's been subscribing the channel and we can hear them loud and clear. And this is, of course, most of the audience is made of crickets and they love to subscribe to the channel. You should too. Our amazing guests tonight are actually dedicating almost 4 years of their lives, in case you didn't know, to study various aspects of galaxies. And galaxies, for those that don't know it, are the best thing about astronomy. And this is not a biased opinion at all. Many people see them as these amazing islands of stars, dust, gas, and space rocks that may host life. And they also contain a lot of dark matter, which we'll talk about next week. Now, galaxies, just like the Earth, are not flat, although they can be way flatter than the Earth. And also, just to clarify, just like Pluto, galaxies are not planets. Now, our guests will tell us more about why galaxies are so impressive, different, and highlight our attempts to understand how they formed and evolved. So in a nutshell, it'll be awesome. By the end, you may even start to think of galaxies as almost being alive. Now, for now, please welcome Heather Wade, Tom Cornish, and Easy Garland. Now, thank you so much for joining me today. I hope you're all doing well and that you've discovered some galaxies or some things about galaxies today. And I see that's a maybe. Heather, since it seems like you've been discovering lots of things, and I hear you're looking for galaxies that are quite far away. But before we go there, what exactly is a galaxy and why are they so cool?
So galaxies are huge collections of stars, mostly always in a dark matter halo. Sometimes they have supermassive black holes in the middle, and they're just really cool because they're huge, they're everywhere. Every direction we look at, we can see them, and they're really interesting and different.
And I mean, just out of curiosity for people watching, the things you're trying to find, how distant are they, at least in light years?
So the things I'm looking for in my PhD are almost 12 billion light years away. So like the very early universe, the first billion years of the universe. Pretty distant, pretty cool. Not everyone can say that that's what they do in their day-to-day life.
I detect some tension. Tom, I know you're also searching for galaxies, which to many people at home, they would call them still extremely far away, although maybe Heather disagrees. Now, are all galaxies the same? So Heather told us what the main components are. Are they all the same?
Well, no, galaxies come in all sorts of shapes and sizes. Sort of our main classes are spiral galaxies, sort of typical like the Milky Way and Andromeda. Your sort of stereotypical picturesque galaxies. But you also have elliptical galaxies, which tend to be sort of more massive and they have less of a sort of distinct structure. And galaxies can also differ in their internal components. So in particular, I'm looking at dusty galaxies. So these have high amounts of dust that obscure the light from them. And yeah, makes them look very different to us.
So basically galaxies that people forgot to clean, to vacuum clean, right? That's why they're so dusty. So you've said that they're quite massive. But so are galaxies like the big thing in the universe? Are they the largest thing that you can get actually?
No, I mean, while galaxies can be very massive, like some of them reaching masses of more than like 1 trillion times the mass of the sun, they're not the most massive structures in the universe. And in terms of gravitationally bound structures, galaxy clusters are sort of the next level up. And these are just essentially galaxies that have grouped together and become bound gravitationally. And they can have between like 50 to thousands of galaxies in them.
It's pretty big. And I guess we will talk about how social galaxies can be and how bad that is to spread stuff, not virus. But Izzy, you study galaxies which are a little bit closer, I would say. So what can we learn from like seeing them with all their amazing details?
So the galaxies that I look at are much, much closer, as David said. And because they are so much closer, we can see them in a lot more detail. We can see very distinct features within them. So we can see some of them might have a bulge in the center. Some of them might have bars of stars going all the way across. And from this, we can see how their shape is and their morphology is influenced by other factors, such as how big they are, how bright they are. And this is all because they are so much closer. So telescopes can see them in much, much higher detail. And that's where you get the really pretty pictures from.
Are there specific kind of details that we don't know a lot about that you're particularly focusing on? So you've talked about the structures within galaxies. Is there anything specific that you're trying to nail down?
So I'm specifically looking at the galaxies that have black holes at their centers, and I'm looking at how the shape can control how quickly the black hole is growing, if it's growing at all. So some of these black holes are growing really, really quickly, and they're chucking out lots and lots of emission that we can detect. Some of them aren't growing at all. They're just happy chilling for now. And we want to find out why some are growing when some aren't. And these ones that are growing, we call them active. So we call them active galactic nuclei. So I'm looking at how these are fueled potentially by like bars of stars, maybe like fueling stuff into the middle of the galaxy, getting it down to that central black hole and giving it lots of food.
So, and I guess the important question, maybe for Tom, on your kind of dusty, not very clean galaxies, do they also contain supermassive black holes, or are supermassive black holes fake news?
Well, it's certainly not fake news, I don't think. I think it's thought that most galaxies have supermassive black holes at their centers. And actually dust can be used to detect activity from a supermassive black hole in the center. So an AGN can actually heat up dust, and then that dust will then re-radiate the energy from the AGN at a lower redshift. And that's how we can indirectly detect black holes in dusty galaxies.
And within those, I guess, dusty galaxies that you can detect because of dust, do they actually benefit from socializing, or are they just like us advised to socially distance so they don't get sick?
So yeah, if a galaxy exists in an environment with other galaxies, the tendency is for that environment to kill the galaxy. Essentially, it suppresses the star formation in said galaxy. So if you're a galaxy and you want to live a long and happy life, then adhere to social distancing. Stay at least 2 megaparsecs away from your nearest neighbor.
There's a very good adaptation of that advice. And Eder, so are the galaxies that you're looking for, do they expect them to be socially distancing from each other, or do they expect to be kind of, close by?
That's a good question. We still, so because it's so far away, and these galaxies that we see are literally like pixels on an image, there's still a lot of research going into whether or not they're in overdensities or are more distant. But I think the ones that we can see, like because we can see them, they're probably in overdensities.
So it probably connects with something we'll talk next week about how structure forms and how this mysterious web of dark matter seems to be the driver. And I guess for those at home that may know this, in our own Milky Way, we have kind of really old structures that gravitate around our galaxy. We call them globular clusters. And Eder, are globular clusters small galaxies, or are they something else?
No, there's something else. So galaxies have the dark matter halo around them, but globular clusters don't have this dark matter. So that would maybe make people think that they're just a rubbish galaxy, maybe. But I think there's something completely separate and definitely worth lots of studying and research about.
And I hear from the voice from beyond that we may have some questions, or at least a question from the billions of viewers that are chatting here right now.
Yes, we have a question from João. What defines a group of stars as a galaxy instead of, say, a cluster?
Eder, do you want to, because I guess it's very related with what we were just saying. So what is the crucial thing that distinguishes a galaxy from a cluster?
A galaxy cluster, or like a star cluster, a globular cluster?
That's a good question. I assume it is a group of stars versus a galaxy.
Okay. Yeah, so the dark matter halo is probably the most important component that the star cluster lacks. And also, I think the current evidence suggests that like star clusters, globular clusters, don't have any active galactic nuclei or black holes in the center either.
Now, before we get a few more questions from YouTube, I guess we do have another one already. So voice from beyond, well, what is the other question?
So João says, but the growth of black holes might not have to do with just shape morphology. What else do you need to take into account in your study?
Anyone wants to answer that? Can we just ignore black holes and just concentrate on the shape? Because apparently they might not have nothing to do with shape or morphology. Izzy, is that a thing you could say for sure, that you could just ignore the role of a black hole?
So as far as we're aware, you can't ignore it. It's currently theorized that the galaxy affects its black hole just as much as the black hole affects its galaxy. So if you've got a black hole that's very active, it's got lots going on, it's firing out jets as things have kind of come in and veered off, and these jets will then go back into the galaxy and land like among all the stars and the dust and gas there. So these will then have an effect. So they are very closely linked as a pair, as a system.
So, and I think, again, before going for more questions, we should go for the now famous round of kind of crazy units, which today also includes a crazy comparison. For those of you that have been practicing with toilet rolls, you may benefit from that practice. We'll see. So hopefully this now works and you can still hear me. Yes, yep. Perfect.
Yeah.
So as I was trying to say, and I was muted by the universe, this question is about just how much stuff there is out there and within galaxies. Okay, so the question is about how many stars there are in galaxies in the full observable universe. So the answer, I mean, the simple answer is a lot. The actual answer we'll now be able to find out. Okay. So you should all be able to see the question. And this is a different question because it's a crazy comparison. And question is, there are roughly as many stars and galaxies as option 1 claims that the Earth is flat. So there's a lot of claims about that. They're all wrong, but there's a lot of them. As many as grains of sand in all of Earth's beaches. C, toilet rolls in the entire planet Earth, or D, dwarf planets in the entire solar system. Now, Tom, you're looking confident. Do you have an idea of just how many stars and galaxies there are in the entire universe?
If I looked confident, it was all a facade, I'm afraid. As many stars. It's in the trillions, I think. Maybe. But yeah, not 100% sure. I would go with B out of those options.
B, okay.
Yeah.
I mean, it's a nice thing to try to verify, right? It's a good excuse to go travel the world once the pandemic ends. Eder, which option are you going for?
I'm also going to go for B because I'm pretty sure Brian Cox taught me that when I was like 15. I think that was in one of his shows.
It's kind of cheating. Izzy, did you also listen to that show?
I didn't, but I'm going with the logic that in our galaxy there's about 1 trillion stars. There's about 1 trillion galaxies that we know of, so we're looking at 1 trillion stars. Therefore, it's got to be B, surely.
And you think there's not enough toilet rolls in the entire planet Earth?
Not at the moment, anyway.
Not at the moment, yeah. So is it B as well?
I'm saying B as well, yeah.
Okay, we have a consensus. Now, what about people at home, all the crickets watching us? What are they telling?
Most of people watching us say it's B.
B, okay.
Yeah, most of them,
well,
yes.
It's too easy. I mean, come on. So, in fact, the correct answer is indeed B. And that is because Brian Cox has kind of spoiled this because it's too easy. But there is a catch. Because we are astronomers, this is only correct actually within a factor of 10. So there are still about 10 times more stars than there are grains of sand across beaches and on planet Earth. So Brian Cox needs to update his number and say it's 10 times more. And as Izzy was pointing out, I mean, for an average galaxy, there's about 100 billion stars, and there's about 2 trillion galaxies. And that's the number that kind of changed between what Brian Cox was probably basing his number on. There used to be kind of 10 times less galaxies. So it means that within a factor of 10, which is fine for astronomers, that is a correct answer. If you care about precision, then no answer was correct, actually. So there you go. But because we're astronomers, we're going to take it. Now, 5 years ago, we announced the discovery of a galaxy that is actually featured here. This is Cosmos Redshift 7. It's actually exactly 5 years ago that the press release went out. And it's really distant. So the question will be just how distant it is. And you might guess that if you've watched any of the other episodes, where this is going, right? And what the crazy units will be. So you will learn just how far away CR7 is right now. And yes, it will be in toilet rolls. So let me just get the question so everyone at home can see. So the question is, how far away is Cosmos Redshift 7, CR7 galaxy now? Okay, this is very important. Not at the time where light came out, and we'll explain and discuss that a little bit. So option A, 5.7 quintillion toilet rolls. That's a number with 18 zeros. Option B, 7.8 sextillion with 21 zeros. Option C, 8.7 septillion. That's a number with 24 zeros. And option D, 6.6 octillion. That's a number with 27 zeros. So we know it's extremely far away, but we need to know exactly how far away it is in toilet rolls. Eder, you're looking confident.
Well, I know of the vague number in kilometers.
Okay.
So, I mean, that's not quite a toilet roll, but I'm going to go with D, 6.6 octillion.
6.6 octillion. I mean, octillion is a nice thing to say. Izzy?
I've got to ask, because I never quite figured out in the first episode whether you're talking about unraveled toilet rolls or fully wrapped up.
Yeah, you should care about the environment, and therefore you should unroll them. Yes.
Should unroll them.
And yeah, unfold them. Yes.
Okay.
Because otherwise it would be even more. Yes.
So I'm trying to think how.
I thought you meant like the toilet roll.
No, it is a standard. We've discussed this. This is very important. Yeah.
This is why I needed to clarify. I'm thinking in that case, it's probably C, 8.7 septillion.
Okay.
But this is very much a stab in the dark.
But I mean, just to clarify, the difference between an unfolded and folded toilet roll is not 1,000, right? Or more. So just to clarify that it's, yeah.
No, but I was torn between the two anyway. So if we're going for the longer unit, I'm going to go for the shorter, for the smaller number.
Tom?
I think I'm going to go with D, just because I think it's very, very, very far away.
Very, very far away. It's, yeah. It's a good enough guess. What about people at home? How far away do they think CR7 is in toilet rolls when you unwrap them?
So we have most of people say D, C, and 1B.
And 1B. So, but the majority B and C, C and D. Is there a clear majority for C or D, or it's basically the same?
I would say D has most people thinking that's the right option.
Okay, so people are following the expert opinion of our guests and the majority, I guess. So the correct answer is actually C. So C is the correct answer. And Cosmos Redshift 7, the name comes from its redshift, which is approximately 7. It's 6.6, but we're astronomers, so that's 7. And light has traveled for almost 13 billion years to get to us. But since then, the universe has been expanding like crazy. So it means that the galaxy is currently about 27.7 billion light years away. And that's 0.3 sextillion kilometers or 0.3 septillion meters. And in the units that we use here, obviously, this is the international standard of when you unroll a toilet roll, it has 30 meters. That's the international system for toilet rolls. Which means that you need to essentially unfold 8.7 septillion toilet rolls to get to CR7. And of course, the problem is by the time you do that, you don't really get to the galaxy because the universe kept expanding. So don't try to do this at home because you will still not get there, or you will need even more toilet rolls. So well done to people that got C right. Do you know who did it? The voice from beyond?
Yes, we have some C.
Do you know who got it?
Amaya. Yes, Amaya.
Of course, yes.
Matt. And Uma.
That's good. Yeah. So we have people getting experts, becoming experts in these units, which is
Yes,
great.
definitely.
For astronomy. Now, we need to go kind of back to discuss a little bit more about how galaxies form and evolve. And also before we have the very first feature of draw your scientific topic, which will debut just in a few minutes, where for the first time live on YouTube, you'll see astronomers drawing the topic that they research. So stay tuned, it's going to be amazing. But going back to discussing how galaxies form and evolve, Heather, the galaxies you study and try to find are so far away that they're in an epoch that we call epoch of reionization. Now, what on earth or not is this? What is the epoch of reionization? And why should we care?
Yeah, so in the very early universe, the very first stars and galaxies were surrounded by neutral hydrogen. But then the stars and galaxies themselves produce loads of high energy photons and radiation. And then this ionized the neutral hydrogen. So the hydrogen just became atoms and electrons. And around the galaxies, these bubbles of ionized hydrogen formed, and they grew and they all merged together until the entire universe was ionized hydrogen. And this is important to study because it's a really interesting part of the history of the universe. We don't really understand what's going on. We're not sure when reionization began or when it ended, or the exact sources that caused the ionized bubbles. Yeah, so I'm trying to find the galaxies that are inside bubbles and learn about them and what they do, and see if we can understand more about this epoch of reionization.
Tom, an important question is, you study galaxies a little bit after this kind of very early stages, right? When they've already formed. So at that point, what really regulates their growth? Is it like, is there an intergalactic government that establishes politics of how much galaxies can grow, or is it set by something else?
Well, it's sort of their environments play a huge role in how much they can grow. So the galaxies I'm looking at, I'm looking to see if these dusty star-forming galaxies at what I would call high redshift. I'm looking to see if they reside in overdense environments. So searching for groups of galaxies around these particular ones. And yeah, the effects of environment on a galaxy, there are several processes that can suppress the star formation in it and stop it from accumulating more gas from which it would grow. Such processes include harassment, when a galaxy passes by the galaxy in question at quite high speed, and this sort of disrupts its material and makes it harder for that galaxy to form stars. There's also strangulation that can be performed by a galaxy cluster, where essentially the cluster cuts off the cold gas supply to the galaxy and sort of strangles it in terms of star formation. So yeah, and the environment tends to work against galaxies growing.
Why are these names so aggressive? This is it's very strange. And Izzy, when were galaxies most active? Is it now, or was there like a period in the past where they formed most of the stars?
So they're mostly mass maiden stars was formed in a period called cosmic noon, which is about half the lifetime of the universe ago, just very roughly. And since then, a lot of the star formation in galaxies has slowed down. So what we're looking at now is kind of very little star formation compared to what we would have seen in the slightly earlier universe.
And was that caused by cosmic austerity, or like was there a crisis? Why was it cosmic Brexit? I mean, what the hell happened?
This is a very good question, and one that we're still looking into as a field of astronomy. I think it was something to do with, obviously, as the universe is expanding, your galaxies are all moving further away. There's more space in between them. So they're kind of chilling out a bit more, but then they can all quickly form their own stars in that period, and then use up all the material that's needed to form stars. So if you haven't got the key ingredients, you can't make the stars at the end. So star formation slows down because we run out of stuff.
And so is that the case that because you study galaxies in the present day universe, are they all done? Or can you still find galaxies that are like, because they socially distanced from all the others, they kept forming stars? Is that the case?
So yeah, there are still star forming galaxies today. It's just a matter that they're not forming it as much. So a lot of the galaxies I look at are not star forming, but you do get ones that are star forming. So local spiral galaxies, which Tom mentioned earlier, you see them in their spirals have these gorgeous, like blue, bright spirals going around. And those are periods of locations even, of high star formation. And that's why you get the brighter color and the more blue colors as well, because they're newer stars. Sorry, David, I think your sound's gone again. And
now it should be fine. I was trying to prevent the problem, so I made it worse. I was saying that it's an amazing way to introduce the brand new feature of the show, which is all about drawing what we're discussing. So just so you're aware, what is going to happen is we're going to draw a galaxy live on YouTube. And it's going to be horrible, but at the same time, beautiful, right? It's going to be art. So hopefully you can still hear me because I've learned something. Yeah, perfect. And the way this is going to work, and people at home can also participate by naming components of galaxies. And if they're real components, we'll have to draw them until we have a decent picture of what a galaxy is. To begin with, I'll start with our guests. And I think Tom's looking particularly confident. So what I'm going to do is I'm going to name a component of a galaxy and our guests will draw it. So let's start simple, Tom. Let's start with the bulge, okay?
Okay. Let's see.
If I can type.
So the bulge at the center, or can I fill this?
It's up to you. You only have 10 seconds before we move, so.
Consider this filled.
Okay, perfect. Yeah, so we have a bulge. So next on is header, and you need to draw a disk. Wow, impressive skills. Is that a disk? Okay.
There you go.
No.
Okay, it's a very bulgy galaxy. We can discuss what it means in terms of what happened. I think it didn't socially isolate. Probably experienced quite a lot of mergers. Now, Izzy, the next component that I'm going to ask you to draw or highlight is a halo.
Okay.
I love the fact that you're actually drawing it and not using predetermined.
Going freehand.
It's perfect. Yeah, it's better than the artistic impressions. I mean, yeah,
Very diffuse halo.
Perfect. Yeah. Now, before we take maybe some components of people watching us and laughing at our skills, Tom, dust.
Yep, can't forget dust. So let me draw some nice red dust lanes in the disk. Perfect.
So yeah, it's looking marvelous. I mean, you should all be hired to, well, I don't know for what, but definitely for artistic views. Eder, the next component on the list is supermassive black hole.
Okay. This should be. Oh, I can't find the shapes. Oh,
Should be quite small, right?
yeah.
Yeah.
There you go.
There you go. It's too easy. So the next one up is outflows. Easy.
Okay, let's get a new color going here. How can I draw outflows? They kind of fall back in sometimes.
So it might be a good time to kind of maybe explain the things that are going on with the galaxies, right? Tom, so you draw a bulge in the center. So what is that bulge made of, typically?
It's typically made of sort of older populations of stars. So as you mentioned earlier, the disk of a galaxy tends to be where most of the ongoing star formation occurs. But towards the center of the galaxy, most of these newly formed stars have died out, and only sort of older, less massive stars tend to remain. And so the bulge actually tends to have a yellower color than the disk as a result.
Now, Eder, you draw a disk, and then Izzy actually got some outflows going away from the disk. So why is that? What the hell is going on with the disk? Is it screaming? Can you now hear me?
Oh, no, I think I'm back. I think my internet
Okay.
went. I hope this is the right answer, but as the outflows caused by like the stars exploding in supernova and driving out loads of material.
Yeah, yeah.
Hopefully.
Sounds about right. And Izzy, you drew this amazing halo, right, of this fuzzy gray thing. What is the gray thing? And could we see it as gray?
So I tried to kind of make it diffuse. The halo is much less dense than the rest of the galaxy, and that's generally where you'll find maybe more metal poor stars, or you'll find globular clusters that Heather mentioned earlier. And it's where a lot of the dark matter lies in the halo as well. Excuse me.
So do we have Voice from Beyond? Do we have any extra components from people watching and willing to see our guests drawing them?
Yes, we have. Emma asks if you can draw a globular cluster. John asks for a supernova going off, and star forming regions if possible for John.
Okay. Eder, I assume you're okay with doing a globular cluster, or a few, right?
I can try. So I'm gonna, oh, it's not very big. I'm gonna draw some blue stars in the bulge. It's not, I can't see that, sorry. I'll just draw. And then, yeah, sort of around, oh, probably not up there, but in the disk as well. Hopefully I've listened to Emma enough this year to know where the globular clusters are.
Or not. Izzy, do you want to draw some star forming regions, I guess, associated with the outflows?
Yes, so we'll go for a nice blue for the star forming regions because they're much younger regions. So we can draw a little region there with that outflow. I'll have another region here going with that outflow.
And what else were we missing? We had globular clusters, star forming regions.
A supernova.
Supernova going off. Yes.
It's kind of there, right? That's driving the outflows. Yeah. I think that's okay. I think the final piece of the puzzle to make it super nice, because you have a big bulge, you probably expect a big black hole. So maybe we should finish off with some jets. I think just to please some people.
That's much better than I could have done.
Yeah.
It's my humble and ridiculously bad contribution. So yeah, that was the very first draw your subject here on the Earth is flat on planet Pluto. And apparently this is a galaxy, according to our knowledge in the 21st century. Yeah, it's beautiful. So we can go back and maybe take a few questions from YouTube. The Voice from Beyond. I think we have a question about Star Wars and also a question about how galaxies form.
Yes, we have. So our galaxies all form in the same way. It is like this. And is Star Wars possible?
Two very important questions, a little bit unrelated. Who wants to go for it? Tom, I think you're looking very confident.
I could talk about galaxy formation a bit. So current theory of galaxy formation in general is that galaxies and structures in the universe in general form hierarchically, starting with low mass structures and then building their way up to more massive ones. And we think that sort of spiral galaxies formed from dark matter halos of smaller mass clumping together, and then gas sort of going where the gravity is. So dark matter being very massive, it attracts other kinds of matter gravitationally. So the gas follows, falls into the dark matter halo, cools and condenses, and due to its angular momentum, it sort of stabilizes into a disk. And that's how we get spiral galaxies, we think. But elliptical galaxies, we think that they're more likely to have formed as a result of mergers between lower mass galaxies. So two spirals might have at some point merged together, undergone all sorts of tidal disruptions and changed shape as a result. And we ended up with a elliptical galaxy. So yeah.
So definitely they're all formed in different ways, but the end product tells us quite a lot about what might have happened. But it's so hard that you never run out of a job, only out of funding sometimes. No, I think it's also time to know a little bit more about yourselves as humans that do science. And maybe I would start with something related. Izzy, what is your favorite galaxy? Do you have one?
Oh,
you don't have to draw it. But...
Good. I think our galaxy ended up looking like a fried egg a little earlier. So I don't really have a specific favorite galaxy, but I definitely have a favorite type, and that is a barred spiral galaxy. They're just so beautiful, especially the ones local to us. You get these gorgeous images of them. There's busy, there's stuff going on, and there's loads to find out about them that we can look into.
Heather, what's your favorite galaxy?
So it's already been mentioned today, but my favorite galaxy is CR7. So as David said before, it was discovered by David in 2015, and it's really far away. Is it not 2015? Oh, no. At redshift 6.6, and I just think it's amazing how we can look at the sky and then we're seeing something that's like 12 gigalight years away, and that means that the universe was only less than 1 billion years old at that time, and we can see this galaxy and we can find out loads about it. We can point our telescopes there and we can like find out its mass and find out its shape and like the things it's doing, and I think that's really cool.
What about you, Tom? Is it a very dusty dust enshrouded galaxy, or do you like more like bluish galaxies?
Well, I guess I have three answers to this question. First would be favorite type. That would be dusty star-forming galaxies, and it's not just because I'm being funded to research them. It's the sub-millimeter galaxies are sort of the type of dusty star-forming galaxy that I'm looking at, and they're interesting because they're undergoing really intense bursts of star formation, and like we're talking like 100 times the star formation rate of the Milky Way. So yeah, they're interesting for that reason. Aesthetically, I'd say one of my favorite galaxies is the ring galaxy. I think it's called Hoag's object. Sort of this perfect ring around a galactic nucleus with this sort of gap in the middle. It just looks very, very cool. And then my last one, in terms of impact on astronomy, I think Andromeda has got to be up there, because that, it's, for a long time it was thought that our galaxy was the only one, until Hubble settled the great debate in the 1920s by confirming that Andromeda was another galaxy, and that completely changed our view of the universe. And so yeah, Andromeda is a favorite for sure.
And of course, done with the technique that Henrietta Leavitt essentially discovered, and then Hubble applied. Now, something else more about yourselves. You now dedicate your time to advancing our knowledge, be it of very distant galaxies are nearby. And starting with Tom, what did you want to be when you were younger? Was this the thing you were dreaming about doing in the future, or is it like more like having a band, something else?
A band was always one of the goals for sure. Up until sort of the end of college, I was convinced I wanted to do medicine. So it was, the choice to do physics was actually like relatively recent, and I think it was only when I applied and got rejected from medical school, and subsequently realized that I didn't actually mind that I got rejected. That was when I had a long rethink about what I want to do. And then at that point, astrophysics became the obvious answer, because it was something that had always interested me. I just hadn't considered it as a career until that point.
It's quite interesting. What about you, Eder?
Yeah, so I think like many people who like science at a young age, I also wanted to be a doctor. But as I got a bit older in high school, I realized that I really, really hate biology, and it's really boring. So, and I started to like physics a lot more. But I wasn't always, astrophysics wasn't always my favorite. So when I first started uni, I actually wanted to do particle physics. So I really liked particle physics in college, and I visited CERN and had a really good time. I was like, yeah, I'm going to live in Switzerland and study particles. And then I realized as I learned more particle physics that maybe it isn't for me, and that I liked astro a lot more.
Izzy, did you also want to be a medical doctor?
I didn't. I was actually originally going to go down a completely different route, and I very nearly didn't do A-levels and went to a college to take up an apprenticeship in farriery, so shoeing horses. And I was sort of convinced by a couple of my teachers that it's a lot easier to switch from academia to vocational than it is to go from vocational to academia. So I had a couple of teachers say to me, he's like, look, just do A-levels, see how you feel. And it was a good decision for me. Like, I really enjoyed physics at A-level, and I'd never really considered science much before that. And then at A-level, decided absolutely love physics. I had a good teacher for it who'd put us in for sort of inter-school competitions and stuff and things like that. And it was when I got to uni that I decided astrophysics specifically was what it was for me.
So I guess what would you tell your younger self if you could, like with the knowledge you have now, if you could say something to your younger self, what would you say?
I would say, I think, work hard at school, because you might change your mind in what you want to do when you grow up.
Solid advice. Yeah. And also, I mean, obviously, Tom and Eder, you didn't go into medical school, but hopefully you're still going to be a doctor. So that's hopefully that'll be an achievement. And so, Heather, what would you tell your younger self then? Like, don't do particle physics, or it's
Yeah.
okay to do it, and then you'll realize that you like astrophysics more?
Yeah, you might have a very strong idea of what you want to do in your head, but it might not turn out like that, and that's all okay. You'll end up doing something, and that enjoying the something that you do is very important.
Tom, what about you? Would you be even more insightful?
I'd say
Invest in SpaceX?
not after the amount of satellites they're putting up.
True.
I would say working in a hospital probably isn't like it is in the TV show Scrubs, so don't listen to that. I would say secondary school physics isn't a solid representation of how physics could be if you continue to study it, because I think in secondary school physics was maybe my least favorite of the sciences. I think it's maybe the curriculum or maybe the way it was taught, but it was only at A level and beyond that I started to get really into it. So yeah, I'd say stick with it.
So I guess we can address the very final questions from YouTube, and I will also have kind of a final round of questions for you. The voice from beyond, I think we do have a question about some mysteries or unsolved questions, right?
Yes, we have. What's the biggest quasar mystery yet to be solved?
There's quite a few. There's quite at least that I can think of.
They're all so mysterious that I can't even think of them. So I'm not equipped to answer this one.
How they form, how they grew, how they know about the host galaxy, so many things. But on that note, actually, for the final round of questions, what I also wanted to know is, what do you think is like the mystery that excites you most, because we'll probably be able to solve it, say in the next 10, 20 years? It could be related with your research or some completely other field. All right, Tom, do you have something in mind?
I would say, I think dark matter. I think if we could figure out what dark matter was, that would be extremely interesting. It was something that's interested me for a long time. So yeah, solving that mystery would be amazing.
Heather.
Particle physics people might beat you to the dark matter though.
Yeah.
I would say that the epoch of reionization, like I spoke about before, like the mysteries of the very early universe would be really cool to like properly understand all of that. And the James Webb Space Telescope that will maybe be launched at some point will hopefully shed some light on that, and like we can see in better resolution even further away. That would be really cool.
Izzy?
I would say for me the biggest mystery is what's making the universe expansion accelerate. Is it some form of like, is our theory of gravity wrong? Is it dark energy, as a lot of people think it is? What is causing it? And I think that would be, even though it's not my field, I think that would be a really, really cool thing to find out. Yeah,
I agree. And it's actually the topic, or all the topics you've brought up. This wasn't arranged at all. This other things that we'll be talking next week, also Wednesday and 5:30. Essentially the things that are out there and they're dominant in the universe, but we really can't see. And dark energy and dark matter are definitely at the top of the list, but also things that people in particle physics study, like neutrinos, which are very socially awkward and they don't interact with almost any other particle. Do we have any final question from YouTube before we finish?
Not really.
Not really? Perfect.
Nope.
That's just perfect timing. I think that's essentially all the time we have for today. So thank you so much again, Heather, Tom, Izzy. I hope you keep revealing the enormous secrets behind galaxies, their shapes, sizes, colors. Maybe even end up doing stuff with dark matter and dark energy. You never know, because as your paths have shown, you can change fields in the future. So it's really brilliant to have you. So let's have a round of applause to you all. So thanks to everyone who watched, participated, and asked questions. We will be back next week to bring you how essentially the universe is full of dark stuff that we don't know almost anything about. And yet another.
The Earth is flat on planet Pluto.
So until then, don't forget to subscribe right here. It's almost like I know what I'm doing. Our YouTube channel, so you can keep up with the videos and also watch previous episodes, which obviously are not as good as this one. It's not about galaxies, but it's still pretty good. So hopefully I'll see many of you next Wednesday at 5:30. And until then, keep looking up and see you next time.
Liftoff of mission 41D, the first flight of the orbiter Discovery, and the shuttle has cleared the tower. Welcome home, Columbia. Beautiful, beautiful.
So I have to take it up the hangar, Joe?
We're going to dust it off first.
3, 2, 1, 0.